Hi, welcome to Social Research Insights. My name is Kamaksha Musnuru. I am Principal Consultant at Social Research Insights. Social Research Insights is not a business organization, it is just a freelance training outfit. This is one of my videocasts which belongs to a series of presentations that related to data analytics for better medical decisions or healthcare decisions. In this videocast, I'm going to explain you the numerical analysis related to Donabedian model. So it's one of the important models quite often discussed in the area of healthcare systems. In case if you would like to know something about the Donabedian healthcare model, you just have to search for Donabedian model in your Google. I think the very first URL will show you what exactly is this model. You can read and understand the various elements of this model. You also have the opportunities to look at the pictorial representations of the model. Just like one, you can select and read about this model. The Donabedian model is well discussed in the arena of the healthcare quality systems. The first block in the Donabedian's quality health systems model is the structure, that which leads to the process, and the process leads to the outcomes. So in healthcare systems, actually the efficiency or the effectiveness of the healthcare quality is determined by the outcomes, and through this model we'll try to understand how the outcomes are influenced by the processes and the structures. And when we speak about the structures, it is simply representation of the characteristics of the institutions and providers. And when we speak of the processes, it is about what exactly the system is going to do for the patients. And as you know, the outcomes is the final the results of the healthcare systems, just like what happened after a process is being done on the patients, whether it is cured or not, or etc. So this is what we are going to study today with the help of numerical data. The purpose of this videocast is to demonstrate as how to perform the numerical analysis, provided we have some certain data from the healthcare systems. So I'm going to show you the data set, and this is actually a spreadsheet application software which is known as LibreOffice Calc, because we always support and also advise open source software to our clients. I am showing you the data that which is collected from some certain healthcare information systems, where we have a data set. In this we have three important columns, as you can see here. Each column represents a data variable. The first variable is the outcomes, and second variable represents the structure, third variable represents the process. And we measure these three variables. I mean, we in the sense like the data is available through certain categories. When we speak about the outcomes, this particular variable is measured with the help of three levels, namely cured, indifferent, and not cured. So this is the outcome. So you can define your outcomes as best as possible, as permitted by the health systems in your, or health information systems in your hospital. And when we speak about the structure, we have two responses for this: proper and improper. Actually these responses were collected from the patients, who is we believe that the patient is always at the helm of the healthcare system or organizations. In other words, I can say this is just a feedback taken from some 27 patients well after they undergone the healthcare process. And now coming to the process, we have two levels, I mean the responses. Each level represents the response. The patients need to give their response as in the form of fair or unfair, something like that. So when we go to the first patient, here the number represents 1. The first patient's response goes like this: cured, proper, fair, which means the outcomes, the healthcare outcome is cured, and the structure was observed as proper, and the process is fair. And when we go to the second patient, his or her responses are like this. The outcomes are indifferent. The patient is not in a position to determine whether it is cured or uncured. Structure is improper. Somehow they perceived or thought that the structure is rather a bit improper, and the process is unfair, or it's because it's a bit unwanted sort of responses to the healthcare system. Given the data like this, so we are going to perform some certain actions. I'm going to use our programming language in order to perform this a particular model called data analysis model called Ordinal Logistic Regression. So we are going to perform or model this data through Ordinal Logistic Regression model, and we are going to see what is the effect of the structure and process over outcomes. So finally, at the end of the analysis, we must be in a position to evaluate the effect of the structure and process, just like here, over the outcomes. So what is the we'll be in a position to evaluate the patient's perception with respect to the outcome, structures and processes. So for that we need to go through some certain steps. Try to open the Word file, and there, step number 1, we are going to do some data import. For that we have a couple of functions available from R, and step number 2, we are going to perform the cross tabs, and we have beautiful functions in R to take care of that. And after that we try to perform some summary statistics. And step number 4, we are going to do some the core part of the analysis, which is Ordinal Logistic Regression. And step number 5, we are going to do some post regression analysis, just like we try to figure out the interpretation by finding the confidence intervals along with p-values. So this is what the summary of the entire analysis that we are going to do by using this data sets. Okay, so let us start our analysis. I already have the script performed. I did the analysis by using some certain statements. As the first statement is going to be importing the dataset. You can see that I used a function called read CSV with another function file choose. So this particular statement is going to import the dataset from our computer to the R session or our workspace. We just have to press. By the way, I'm going to put this script file below in the description to this video. You can just download and just keep pressing Control Enter. So once you press Control Enter, then it will take you to the your Nautilus, the window. We need to go down to the directory where we have kept the dataset. I already saved my dataset in the form of CSV file. I think you have a lot of information online as how to convert the Calci spreadsheet into a CSV file. Here, this is the CSV file which I got from the my actual dataset, which is ODS. Actually, ODS is the format which we obtain from the LibreOffice Calci. Press Enter. Then we have we literally created an object called df through this statement, and now let us execute the function names. So these are the names that we, and optionally you can also see the first 6 rows of the data set by executing the function head, which is not there in the script file df. So these are the first 6 records of the dataset. The first record is the responses of the first patients, as I have shown you in the LibreOffice Calc file. And in case if you want to see the entire dataset, you just have to execute the name of the object, in this case df. So you have the entire dataset. You can also see optionally edit df. So you'll see the dataset in a very proper fashion, just as we have seen in the LibreOffice Calc spreadsheet. This is a spreadsheet view of the R programming language. And now we are going to perform crosstabs with a couple of functions. One of the important functions is lapply, and at the end of the statement you will find the function called table. So what I mean actually, take this data set with all its columns and try to form it in the form of a table. So let us execute this statement by pressing the Control Enter and see what's going to happen. So for outcomes, these are the levels. We have 10 queued responses, 10 responses for queued, level queued. In other words, I can say there are 3 levels. For first level, name of the level is queued. We have 10 responses. Second level, indifferent. We have 8 responses. And third level, not queued, we have 9 responses. And for structure, which is a variable, for level 1, which is improper, we have 13 responses. Level 2, proper, we have 14 responses. And now let us form the multivariate crosstab with the help of functions ftable and xtabs, which are by default available from the R base, for all these 3 variables. And this is the statement that we need to execute in order to get the multivariate crosstab. Press enter. Then this is the view of the outcomes. For outcomes, queued, indifferent and non-queued. For structure, proper, improper. So for outcome queued, we have both of the responses, improper and proper, and both of them organized against the process for which we have 2 responses, fair and unfair. For instance, we have 4 responses that falls under the category queued, improper and fair. So this is perhaps the maximum number of responses that we observe for these 3 categories. And now let's go for the summary table. So you can go for the summaries of each and every variable. Summary function is very much useful function in order to make the summary statistics for variable by variable. So here this statement makes the summary statistics for the first variable, that is outcomes. So let us press Control Enter. Same way we have for outcomes, since it is a categorical variable, we don't get the mean, variance, standard deviation, etc., etc., etc. We want to get the frequency table for this particular variable outcomes. So we have 10 responses for queued, 8 responses for independent, and 9 responses for not queued. Now let us go to the very core of the analysis, that is ordinal logistic regression. This is actually, there is a wonderful function named polar, which is available from the package MAS. Polar stands for the proportional odds logistic regression. So we are not only performing the logistic regression, but we are performing a peculiar case called as proportional odds logistic regression. And if you want to know what it is, you just go to the Google and search for the formulas, methods, model, and there is a lot of information online. So to do that, we just have to make use of a special function, as I said, which is available from the MAS. If you want to know more about this, go to the console, help, polar. So press enter, then you'll have a beautiful manual for that. You can read entire information related to this particular method or model, which is called polar. We also have a couple of formulas and functions, equations available for that. And there are also examples just below the. You can also make you can make a separate window of it and read the entire and bottom of this manual you have wonderful examples. But for now I'm just going to develop on our datasets. The meaning of the first one is I'm creating an object called fit using a special function for proportional ordinal logistic regression. The response variable is outcomes, and explanatory variables or regressors are structure, process. Take all of them from the dataset df, and also don't forget to make the Hessian function. And Hessian function, Hessian matrix. Hessian is very, very important in order to create the standard errors, which is not important for us but important for the R, in order to create the standard errors, which is one of the essential ingredients in the output of the logistic regression. We just have to press the enter. Now we created the object fit. Now let us see what is there in the fit. Press Control Enter. The very first part of it is the call, which means the fit. In fit we have an ingredient called call. This shows our formula. This is the formula for the logistic regression. Next, immediately to the call, we have the coefficients. We have two coefficients, one for the structure where proper seems to be very important response, and a coefficient for the process where unfair seems to be very important response in the model. So these are the coefficients. I think both of the coefficients are positive. That's good actually. And we have the intercepts. The intercepts are figured out as the form of the queued, given indifferent given not queued. For time being it is not important for us, and maybe perhaps I will explain you what is the meaning of this response. The coefficient for the intercept for queued, given indifferent and something. I mean, this is actually the cut points in our programming. In Polar methodology, in modeling, we call these as cut points, and these are the cut points for the latent variables. Actually, we don't take this particular ingredient into the consideration when we are, because for that matter, intercept is not very much important for us to interpret the. We need to depend on the coefficients and the p-values in order to assess the importance of the structure and process over outcomes as far as this particular model is concerned. And the last ingredient, we have the residual deviance. This is some extent -2 log likelihood, which is very, very essential when we are comparing the models. And we also have the AIC, which stands for the Akaki Information Criterion. Again, this is also very, very important when we are comparing the models. But for now, we don't have too many models. We have only one single model. We don't think this particular information is important for us to interpret. So finally, we are going back to this particular coefficients in order to interpret the model. And for that, we need to have the coefficients. In order to make the p-values and the coefficients, we have a couple of activities or tasks that we need to do. I'm going to create a particular function called seed table, and there is a wonderful function called coef, which stands for the coefficients, and we need to take the coefficients from the summary of the fit, which is again an object which I created as in the flow of the analysis. So let us press enter. Now let us see what is there in the seed table. And you can see that we have the responses, and these are the actually regressors. Explanatory variable. In layman words, I should say these are the independent variables. So this is the coefficient for the independent variable structure. This is the coefficient for the independent variable process. And we have the standard errors, and this is what exactly I was talking a minute ago. We need this standard error is being computed by using the Hessian of the model, and we got the t-value. This is what appears to be very, very essential for us to interpret the model. But unfortunately, we don't have the p-value. This particular function, Polar, does not return the p-value. So in order to find the p-value, we have a manual procedure that we can follow a particular. We can make use of a particular function called p-norm, which means we are requesting the R language to return the p-value for a normal distribution. We are assuming that this is actually the underlying distribution is the multivariate normal distribution. We can make use of this function p-norm and save those p-values for all these t-values in the object, which again we are creating here, p-values. So we are creating an object p-values, and we are using a function called p-norm for all absolute values of the t-values, which is there in the C table, and take the two-tailed distribution. So we request R to make lower tail false and make the two-tailed p-values. So let us execute this function, again pressing Ctrl R. We got this. I'm sorry, this is actually, there is a typo in my. We created the p-values. Yeah, we created the p-values. Now let us see the p-values. These are the p-values for each and every constant that we have in the model. Now let us make a gimmick that we are just going to combine the coefficients along with standard errors along with the p-values. Let's see what is there. So we have a beautiful data frame for the regressors. We have the coefficient and standard error, t-value and p-value. So let us go inside into this. Let us interpret the coefficients. I think we don't have any significant results in our model. All of them are insignificant. I think we don't need to be careful about this structure and process as far as the outcomes are concerned when it comes to this particular data set. But how are we going to assess this, the impact or the effect of this two? Because we have some certain fashion to interpret the logistic regression, like what is going to happen in the outcomes when we increase or when we go from one level to the other level of the dependent variable. For instance, when we go from one level of the structure to the other level of the structure, let us go to the levels here. Like structure, we have the proper improper. For instance, if I am going from proper to improper, then what is the impact of the outcomes? How am I going? Am I going from the queued to the indifferent to the not queued, or am I going to the not queued to the indifferent to the queued? So what is happening in this model? For that, we need to have the confidence intervals. Again, I'm going to create a particular object called the CI. I'm going to make use of the function confint or model, name of which is fit. So let us Control Enter, execute that, and we have the CI table. Let's see what is there. CI. We have the confidence intervals. I think we have 0 petty well in between the both of the lower limit and upper limit. That's good. So we have model is within our control. And next we are going to create the odds ratio by executing the exponential function. Usually in logistic regression we have a beautiful function e to the power of beta. That is, you just have to read that. Logistic regression. We will try to figure out the odds ratio by computing the e to the power of beta. Beta is actually the coefficient. Here you see the logit, and we have somewhere, I think, yeah, this is actually the exponential. See, here you have the e to the power of beta. Odds is equal to p by p, 1 minus p, which is equal to the e to the power of beta. And you can also develop on the, you can go to the Wikipedia where you'll be having much more. So I don't have the time to explain you everything. Perhaps I have to make one more video to, yeah, here you can see that the odds ratio e to the power of beta, OR, is equal to e to the power of beta, something like that. So I'm using a special function which is CXP, which transforms the data into exponential data. and over the data matrix, which is comprising of coefficients and confidence intervals. So let us let us execute this statement. We got the odds ratio and the confidence intervals. Both the odds ratios are pretty accommodated in between the lower limit and the upper limit, so the model is pretty well in our control. So this model is quite useful to interpret the odds ratio. And coming to this particular value 2.28, when we move from one level to the other level, as far as structure is concerned, and we are actually jumping 2.28 times the for outcomes. So when we move 0 to 1, we are actually making a leap of 2.2 times, 2.3 times roughly when outcome comes. That has, I think the structure has very good impact on the outcomes, and that is actually double, isn't it? For one level we are actually leaping 2.3 level, three times the outcomes. That makes quite a phenomenal sense as far as this data is concerned. So this data is very much useful in order to assess the outcomes, assuming that it depends on structure and process. And now coming to the process, though it is not that strong as structure, but it has a very positive impact on outcomes. So when we move one level, that is from 0 to 1, maybe unfair to fair, we are actually making a phenomenal leap from 0 to 1.10, which means again it is very positive, and we have it is positive and also good effect on the outcomes. So this way we can perform the proportional logistics ordinal logistic regression in R in order to assess the model, which is very considered as one of the famous model in healthcare information systems. I can say quality systems in healthcare organizations. So in this video we have assessed the model Donabedian invented long back, and evaluated this model by using some abstract data through which represents Donabedian's three variables, that is outcome, structure and process. Thanks for watching my video. If you like, press the like button, but don't like the unlike button, and subscribe to my video channel for the new content. Thank you very much.